Good morning. I'd like to make a video over IXL P13 rotations, finding the coordinates, because a lot of you are having trouble with that. So this one starts with the point P is at -6,3 and it's rotated 270 degrees clockwise. So when I think about 270 degrees clockwise, that means it's 3/4 of the way around the coordinate plane in the way that the clock moves. So there's 1/4, that's 90 degrees. There's 2/4, that's 180 degrees. 3/4 will be 270 degrees. So the first thing I notice is it ends up, if this is quadrant 1, this is quadrant 2, this is quadrant 3, and this is quadrant 4, I notice it ends up in quadrant 3. So that's a hint to me that I know that my answer is going to have a negative there because we have a negative x and we have a negative y. So first of all, I already know the signs of my answer. The next thing that I want to look at is I want to start with the original coordinates. The original coordinates for point P are at -6, and 3. When I rotate it, just ignoring signs for a minute, when I rotate 90 degrees, the y-axis comes down here and becomes the x-axis, and the x-axis comes down here and becomes the y-axis. So basically what happens is that these two flip-flop. So the 3 becomes the x coordinate, the 6 becomes the y coordinate. And then that's at 90 degrees. At 180, they turn again. So at 180 degrees, the y becomes, the 6 comes back to the x, and the 3 comes back to the y. Again, every time we turn, this y comes down here to the x comes down here to the y. And I'm ignoring signs for right now because that's going to make our life a little bit easier. When we get to 270 degrees, we know that the 3 comes back here to our x coordinate and the 6 comes back here to our y coordinate. And then I go and find my signs by looking at which quadrant it ended up in. So in this case, it's a -3 and a -6. And I can go through and watch which sign occurs here every time. The -6 actually, when it moves over here, became a +6. This 3, it was heading up, now it's heading to the right, so it was positive. And I can go through on all of that, but I think it's easiest just to think of it as they switch every time you turn, and you can go and find the signs depending on which quadrant it's in at the end, just to simplify your life. All right, so let's look at this again. We're looking at point L, and again, we're going to look at 1/4 is 90 degrees, 2/4 is 180, 3/4 is 270. And when I say fourths, I'm really talking about the fourths of a circle because a circle is 360 degrees. And so when I'm talking about fourths of the way around the circle, I'm thinking of 360 divided by 4. That's why it's 90, and then half of 360 is 180, and 3/4 of 360 is 270. And again, if I went all the way back around the circle, I would end up exactly where I was at 360 degrees. So we're looking at point L, and again, I'm going to ignore signs for the time being. I'm looking at 5, -2. And this time we're looking at 270 degrees counterclockwise. If the clock moves in this direction, counterclockwise means it moves backwards from the way the clock goes. So 270 degrees, there's 90, 180, 270. And this gives me the hint that, again, I'm going to have a negative, just like I did in the last problem. And so every time that it switches, the x comes up here to the y comes down here to the x. And so the x coordinate becomes the y coordinate, and the y coordinate becomes the x coordinate. So the 2 comes here to the front, and the 5 goes here to the back. When I'm looking at it at 270 degrees, it flips again. I apologize. I have to go back here just for a second. This was not the 90-degree turn. This was the original point P. And so this was when it went 0 degrees. That was our original point P. This is at 90 degrees. That's when it turned once. This is at 180. This is at 2 turns of the coordinate plane. So the 5 comes here and the 2 comes here. and 3 turns of the coordinate plane, my 270 degree, which is what I'm looking for because that's what the problem's looking for. It flips back over here and the 2 comes to the front, the 5 goes to the back. And because I'm looking at quadrant 3, I know it's negative, negative. So I'm looking for something that's at -2, -5. All right, let's clear our screen. And we're going to look again at 180 degrees. So if our original point is at 2, -6, when it goes 90 degrees, I'm going to be switching. So 90 degrees, this -6, the 6 is going to come to the front. And again, I'm ignoring signs for right now, just to make our life a little bit easier because it really depends on which way it goes. So this is 90 degrees. It switches. And what I'm saying it matters is because if it's turning clockwise, the positive x becomes the negative y. But if it's turning counterclockwise, the positive x becomes the positive y. So the direction of the turn makes a difference in this case. The directionality, the way that it goes either clockwise or counterclockwise, is going to determine the change in the sign, the directionality of the turn. And so for our purposes, I'm not going to worry about the signs of them until I'm done, when I figure out which quadrant it's going to end up in. So the 6 comes up over here and the 2 comes down over here because the x coordinate, here's our 2, our x coordinate as it turns counterclockwise is going to come up here and it's going to become our y coordinate. So that u is now going to be 2 up from the x, whereas it was 2 to the right from the y before. So as it turns, it's going to come like that. And it was 6 down on the y-axis. Now it's going to become 6 to the right on the x-axis. That's why they're turning. That's why it's happening. And when I go to 180 degrees, now as it turns again, the x that was facing to the right is now going to be facing to the left. And so this 2 comes back over here, and now it's on the x quadrant again, our x coordinate again, and the y is going to come back over here. This 6 is going to come back over here, and it's going to become the y coordinate once again, because what was heading down as it turns is now heading to the right. So that's why it was an x. That's why it was in the x coordinate there. And then it turns again, and it's going to become the y coordinate. Now, as I turn, and I want to make sure that you can really see what I'm looking at, and I meant to delete just a little bit, not everything. It says counterclockwise. So there's 90 degrees counterclockwise. Here's 180 degrees counterclockwise. So it's going to end up. So I'm going to look over here and notice that it's in quadrant 2. Quadrant 2 has a negative x value and it's going to have a positive y value. So that tells me that in my answer, I'm looking for a negative x and a positive y. And since it was at 2, -6, again, I'm just looking at 2, 6, it's going to switch to 6, 2 when it goes 90 degrees, 1/4 of the way around the circle. So in this, if it had gone right here, it would have been positive 6, 2, because it would have been positive, positive. But as it turns, it's going to become 2, 6 again. But now the 2 is negative because it's in the negative x direction, and the 6 is positive because it's in the positive direction. So really the algebraic rule for that is xy for a 180 degree rotation becomes negative x, negative y. But the easier way of really thinking about that is just it switches every time that you go 1/4 of the way around. So when you go 180 degrees, it switches. 6 comes over here, 2 goes over there. But then when I go 180, it switches back, and then the 2's are in the front again, then the 6 is over here. And then what I do is I look at this quadrant and I notice the negative x and the positive y. I put my negative here and I leave my 6 positive. And as you notice, -6 became +6, just like my rule is going to say. The negative version of -6 is +6. And the negative version of +2 became a -2. So the negative x, negative y rule really did work in this case. I just think that it's easier to work with it by remembering that switching, that the x switches to the y and the y switches to the x with a 90 degree turn, with every 90 degree turn. So this is -2, +6. Uh-oh. It says -2, +6. I must have written it wrong. No, I forgot the negative sign. Darn. Oops. And it happens, we're not perfect, but funny. So we pretty much have this idea. As this is rotated 90 degrees, that's only 1/4 of the way around the circle. So the 2, 4 is going to become 4, 2, because it's only going 1/4 of the way around the circle. And I'm going to determine the sign by looking at the direction. Clockwise means it's going in this direction. And so since it ends up in the quadrant 4, it's negative, negative. And therefore, it's going to be -4, -2. Looking at this problem, it's rotated 180 degrees. So it's going to switch once for 90 degrees, and then it's going to switch back to get to the 180 degrees. So I know that in this case, it doesn't even matter because they're both fours. So 180 degrees clockwise means it goes over here and it goes over here. As they switch, it ends up in quadrant 1. Quadrant 1 is positive, positive. So instead of -4, -4, it's going to become +4, +4. Same thing's going to happen with all of these. You're going to follow those same exact rules. And so as it's rotated 270 degrees clockwise, I'm going to draw it so that I can see it. 270 degrees clockwise that's 90, 180, 270. So I know that all of my answers are going to be in quadrant 2. Quadrant 2 has a negative x value and a positive y value. So I'm going to start by just going ahead and putting all my negatives here because I don't want to forget them like I did before. And I'm going to think about the switching. So they switch over here. So they switched. If it was, in this case, it was 6, 4. So this would have been 4, 6 as it switches 90 degrees. As it switches 180 degrees, it became 6, 4. They switch back. And again, with the signs, this would have been positive and this one would have been positive and this one would have been negative. Using this quadrant, it would have been -6, -4. But then as they switch that last 270 degrees, they switch back and the 4 comes first and the 6 comes later. And because they're in this quadrant, I know it's going to be a -4 and then a +6. So once I have one of those rules, I've got -4, +6, I know that they're going to be switching. So I've got 4 over here and 6 over here. Same rule, the 7 is going to come to the front, the 6 is going to go to the back. And same rule, the 7 is going to come to the front, the 9 is going to go to the back. Now, if I were to graph that, and I do want to graph it just to make sure it looks good, just for you guys. Obviously, you're not going to have to do that on your own because you can't draw on it. But I'm going to go and plot these points just so you can see them. And I just realized that I should have 4 points because it's quadrilateral. So again, I'm going to have a negative, and then the 4 is going to come into the front, and the 9 is going to go to the back. I'm going to plot those 4 points and just make sure that they make sense. So I've got 1, 2, 3, -4, 1, 2, 3, 4, 5, 6. This is going to be P prime. I've got -7, 1, 2, 3, 4, 5, 6, 7, +6, 1, 2, 3, 4, 5, 6. This one is going to be Q prime. I've got -7, which I already had. This 9, so this is 6, 7, 8, 9. There's R prime. And finally, I have -4, which we already had over here. This is 6, 7, 8, 9. This is S prime. And I hope that you can see that as it turns, if I look at this as right here, I kind of just look at it right here. 1, 2, 3, 4, 5, 6. So it's 6 to the right. As it turns this way, this is going to become 6 down and then 6 to the right again. And then it should be 6 up. 1, 2, 3, 4, 5, 6. And I can, in fact, see that that's where it's ending up. And what was QP over here is still Q prime P prime. And what was RS is still R prime S prime. So it is, in fact, turning that 270 degrees to help you visualize that turn. All right, I'm going to jump another level, see if we can get into the challenge section, sort of the hardest problems, because I don't think it really gets any more difficult than this. So a 90-degree rotation, I know they're going to be switching. So I already know that uh, 90, they're going to switch. 180, they're going to switch back, so they're going to stay in the same direction or the same order. 270, they're going to switch back. So those 90s and 270s, you're switching your X and your Y. So I already know it's going to be the 6, 8, 10, and 8 are going to be my X coordinates. And I know that the 4, 9, 4, and 0 are going to be my Y coordinates. And I'm going to look at it, it's going counterclockwise, so it's going 1 in this direction. So because it's in quadrant 2, all of my coordinates, my X coordinates, are going to be negative, and my Y coordinates are going to be positive. And there we have it. I already know it's right, but I am going to plot it just to make sure that it looks right. And so I've got -6, 1, 2, 3, 4, 5, 6, +4, 1, 2, 3, 4. And that should be B prime. I've got -8, that's at -6, so -8 is there. 9, 1, 2, 3, 4, 5, 6, 7, 8, 9. And that's going to be C prime. I have -10, 1, 2, 3, 4, and that's going to be D prime. And you'll notice that D and B are across from each other. D and B were across from each other this way. So that makes sense. And I'm looking at -8. So that's -10, -9, -8, 0. And that's going to be E prime. And if I look from C to E, they are across from each other, and they're 1, 2, 3, 4, 5, 6, 7, 8, 9 across. And these are 9 across in this direction. And B prime and D prime are across from each other, just like B and D were across from each other. And I hope you can see that this was sitting on the on that axis, on the y-axis, and so now it's sitting on the x-axis. And this was just 1 away from the edge, and it's still just 1 away from the edge on my figure as opposed my image as opposed to my pre-image. They look exactly the same. And you can actually see on this one, I think even better, that the y-axis has now become the x-axis. So whatever was in our y has now become in our x. And in this case, the x is negative. And that's what, this was a positive y. These are all negative on this negative x-axis. And that's why they're all negative here. And these were on the positive x over here. And now they're, as it turns, 1 turn of the circle, 1/4 of the circle around, this is going to become a positive y. And so all of my x coordinates have now become y coordinates, and they were heading to the right, which is in a positive direction, and now they're heading up, which is in a positive direction. That's why they maintained their sign. I hope this video helps you to understand IXL P13 rotations. If you need any extra help, please give me a call. Thanks.